3 deadly bolting mistakes in steel structures and how to avoid them. If you work around steel structures, whether you're an engineer, a site supervisor, a student, or you just love real-world engineering like I do, then today's topic is incredibly important. We're talking about 3 deadly mistakes in tightening structural bolts that can literally lead to connection failure and building collapse. And trust me, these mistakes happen more often than you think. I've seen them on job sites, in inspections, and even in big projects where people should know better. So let's break them down slowly, clearly, and with real site examples. Mistake number 1. Using an impact wrench for final tightening. A very common scene on steel sites is someone hammering away with an impact wrench and saying, "There, it's tight enough." And if you're lucky, it is. But in real engineering, lucky is not a strategy. Impact wrenches are great for snug tightening, meaning bringing the plates together. But they are not calibrated, they are inconsistent, and they often over-torque or under-torque bolts. With high-strength bolts, especially A325 and A490 bolts, proper tension is everything. Too little tension equals slip and joint movement. Too much tension equals bolt necking, thread damage, and early failure. Let me give you a real example. A contractor once over-tightened every bolt on a bracing connection using a massive impact gun. The bolts looked fine until the building started vibrating under wind load. Several bolts fractured, the brace loosened, and the entire frame twisted. Expensive mistake. Preventable mistake. Correct method. Snug tight with impact wrench. Final tightening with calibrated torque wrench or turn of nut method. Engineers don't rely on noise and vibration. We rely on controlled force. Mistake number 2. Incorrect washer placement. Washers look simple, but they play a huge role. High-strength bolt assemblies need proper washer placement to distribute pressure, protect plate surfaces, prevent bolt head rotation damage, maintain correct tension over time. And yet, washers get flipped, misplaced, or worse, forgotten entirely. In slotted or oversized holes, washers must be placed under the turning element or on both sides, depending on the standard and detail. Skip a washer or put it on the wrong side, and here's what happens. The nut bites into the plate, friction increases, bolt doesn't achieve proper tension, plates deform, and over time the connection loosens. Just imagine a beam-to-column joint under cyclic wind or seismic load. That connection will slowly open up and slip. Tiny part, big consequences. Mistake number 3. This one is the silent killer. So many crews tighten bolts and walk away without verification. Engineering code doesn't say, tighten until it feels good. It requires evident records inspection, because friction-type connections rely on clamping force, not shear on the bolt body. Common approved verification methods: calibrated torque wrench, tension control bolts, direct tension indicators, pre-installation testing, and inspection logs. If there's no record of bolt tensioning, then, as far as engineering practice goes, the connection was never properly installed. Think of a bridge, a crane support, a bracing system. Bolts don't fail all at once, they loosen over cycles, then one day, snap. And by then, it's too late. One more mistake: not cleaning surfaces in slip-critical joints. If your design requires friction-type bolts, rust, paint, oil, or mill scale between plates means zero friction. Always clean, grind, blast, or use approved surface prep. Remember, steel doesn't fail because it's weak. Steel fails when people take shortcuts. Bolted connections hold buildings, cranes, bridges, towers, and lives together. It takes just a few extra minutes to do them right. But it only takes one shortcut to cause a disaster. So whether you're tightening bolts, supervising, or inspecting, follow standards, use calibrated tools, and document everything. Real engineering means real responsibility. If you enjoyed this deep dive and want more real-world structural engineering lessons, hit like, subscribe, and share with someone in construction.